Okay, so SDK has popped up here. It automatically imported our hardware. You can see Design 1 wrapper, hardware platform 0. That our Design 1 wrapper in Vivado, that's the name of our wrapper. So I'm going to go ahead and maximize SDK. If I haven't said it already, SDK stands for Software Development Kit. So we're going to go up to File, New, and we're going to click Application Project. This is where we're going to make our code. We're going to call our project name. I'm going to name this correctly because I didn't name the HDL correctly. Remember, the HDL was a AND gate, A-N-D, but I named it NAND gate, which was a dingus move, sorry. But okay, we're going to name this project. Remember at the beginning, I showed that we were going to have the programmable logic, or the FPGA, do the AND gate, and then the software and the processing system do the NOT gate. So for this, our C code is going to be called just NOT gate. So we'll call our project NOT gate. All of this default is fine. Our processor is, yes, that's correct. C, board support package. Don't click finish. Actually, click next. If it's not already on Hello World, click on Hello World. That's going to bring up everything that we need, and we can just delete all the Hello World code. Click finish. And sometimes it can take a little bit, but if you're on, like I had already mentioned, I have it's not very old, but it's a little bit older of a computer. It helps if you let the workspace build. Down here, if you see building workspace, sometimes you can't do things until the workspace has built fully. So I usually just like to wait until that's done. Okay, so now that the workspace is built, we can go to NOT gate, expand it, and expand the source, and we're gonna right click on this hello world, and I'm gonna rename it just for myself. You can keep it as whatever you want to, but I'm gonna call it notgate.c. And whoops, I totally clicked on the wrong thing. Open up notgate.c, click on it, and it's going to say la-di-da, da-da-da. We're just going to delete this stuff, and I'm going to say that this is a test application for a PL to PS interconnect. And we'll delete that because we don't. Oh, wow. That's a lot of stuff. We'll delete that because we don't need it. Okay. We're going to include standard io.h, include platform.h. We don't need this xio_printf.h. This is actually a neat library, and you can see here, even though it's C, it just says print versus a printf statement. Xilinx made their own function print. I think it has like a little bit less overhead than a regular printf statement, is what I have read, but we're not going to need that. What we are going to need is xgpio.h, and we're going to need one more hash include xparameters.h. Let me make sure I spelled that right because I already because I always spell this wrong. Sparameters.h. Yes. Okay. If you go over here to the outline, you can see all these different libraries that we have, and we can click on them. So let's see xgpio.h. Let's see what that does. So it has all these like some structures, some functions, and we're going to be using these functions. And you can just go in here, look at the outline table for what you want to do. You can see this stuff is similar to a microcontroller, where we're going to set the data direction register, xgpio, get data direction register, discrete write and discrete read. We're going to be using to write values to outputs, so you can do some interrupt stuff like that. So good library. xparameters.h has some, if we go down here, it just has some definitions, so those we're going to want to include as well. Go back to notgate.c, and this init platform, that's just going to initial, if I can get my commenting right, initialize the platform. I spelled initialize wrong, but that's okay. I'm not going to fix it. Okay. We're not going to need this print hello world. So first what we're going to do is say xgpio, and we're going to create two instances, because in the processing system, if we go to Vivado and look at our block diagram again, and we zoom in, if I can get this to work. Yes, okay. So we have two axis blocks. That means we're going to have an input and we're going to have an output. So if we go to SDK, we need to create two instances of this xgpio. So we're going to say input and output. Okay. And then we're going to have an integer, and we're going to just call this A. And A is the input to the NOT gate. All right. Now we need to initialize our, whoops, sorry, that's my phone going off. We need to initialize our xgpio. xgpio is the axis GPIO that we had used. Sorry if I got a little quieter there. I was leaning back. Is the axis GPIO, xgpio. And we need to initialize that. So we're going to go xgpio, and if you hit Control Space, it's going to pull up what you're typing. And so here we go. Click Enter. xgpio initialize, and then it has some helpful hints, instance pointer, and we're going to say and output, or let's start with the input. And input, comma, U16 device ID. This is where the xparameters.h comes in, and we're going to click xgpio xgpio1 and device ID. Okay, important thing to note. Make sure the device ID matches the instance input / output. Okay, what do I mean by that? I mean, see how it says xpar underscore axis-gpio 0. We want to make sure that that 0 instance matches our input to the processing system. So if we go to our block diagram, we see this is our x axis-gpio 0. Okay, that's our 0th or first instance. Here's our first or second instance, however you want to describe it as. We have two instances, one, and then that's the second one. So this one's labeled 0, And we can see two ways that it's an input. One, it says GPIO underscore IO underscore I. That I stands for input. The second way we can tell is this little triangle. It's pointing inwards, meaning it's an input. So we're good there. We have the input matched up with the GPIO 0 device ID. Similarly, we need to do that for the other actually GPIO block. GPIO underscore init, and then remember control space and then enter once you have the correct one, and output comma, ooh, sorry, I just got dry throat. And xpar control space. Now we're going to want to find the right one. Remember, this is going to be the instance. It's the second instance, but it's labeled as GPIO 1 instead of GPIO 0. Hit that, semicolon to finish it up. Okay, and we should be good to go there. I'm just going to make a little comment up here that says initialize axis GPIO. Okay. Code. This is sort of like the main part of our main program. So we've initialized it. Now we need to do the data direction register. So x GPIO, control space again to see, and set data direction. Enter. Instance the input. Okay, now we're on unside channel. You can see, oops, where did that go? Anyways, now we need to enter the channel. When we were looking at the block diagram, and let's just click on this for a second, and we go to IP configuration, I said don't click on enable dual channel. Because this is just a single channel, actually GPIO, all we need to put in this, in the channel box, is 1. If there was 2 channels, you need to do 1 or 2, depending on what you wanted to do. Okay, comma, and then now we need to say if it's going to be an input or if it's an output. And for the data direction register, I guess that's a poor thing because DDR is also memory. Data direction reg input is 1 and output is 0. So if you had 4 bits wide that are all inputs, you would set it to hex F, and that would say that all of those 4 bits are inputs. Since this first input is an input, we're just going to say 1, and now we need to do the data direction register for the output. Set data direction, click enter, xGPIO instance, and output unsigned channel, single channel, so we're just going to hit 1, and the direction mask, it's an output, so 0. Opposite of Atmel, I believe, is what uses. Atmel is kind of opposite of stuff. Okay, now we're going to make the NOT gate. So while 1. Okay. We're going to say if A equals 1, go down. So if the input is 1, the output, we need to make an output integer. Oh my goodness. Int y. And y is output of NOT gate. Okay. So now that we have that, y is equal to 0. Okay, so set y opposite, because it's a NOT gate. And I spelled opposite wrong, but I do not care. Else, so if a is equal to 0, y is equal to 1. So just invert it. Then what we're going to want to do is we need to say, how do we know if a is equal to 1, and how do we say, okay, if y is equal to 1, then we want to set the LED is equal to 1. So we do that by using the functions from xgpio.h, and those are going to be discrete read and discrete write. So the first thing we're going to do, we're going to put this before the if-else statement, is we're going to do a discrete read. What that means is we're going to read the state of this little input instance. So we're going to go xgpio dis and then control space. You can see we have all these discrete clear, read, set, write, and we're going to be using the read one to get our data. And we're going to get our data from the input and then unsigned integer channel. Channel is 1, and we are going to say a is equal to whatever this value returns. Okay, now we need to connect this y integer to the output. So we're going to use a discrete write. So xgpio dis control space discrete write. Okay. And we're going to need the instance pointer and output, the channel, which is 1, and the data, which is y. Okay, semicolon, clean up some spaces here. Okay, clean up platform. That just, I can't remember what that does right now because I ate too much pizza, and yeah, return 0. Okay, click Control S, and when you click Control S, it's going to build the project for you automatically. So let's just get like a big, let's maximize this and get like a bigger picture idea here of what we just did. Okay, the FPGA, go over this big picture wise. The FPGA fabric, we're going to have this AND gate, A-N-D, not NAND, what we coded, it's A and B, which is attached to switch 1 and switch 0. So we're going to have the AND of switch 1 and switch 0. The output of that is going into the ZYNQ processor. The ZYNQ processor is taking the NOT of that input and outputting it to this LED right here. So we already had written the Verilog code. We have the ZYNQ processing system, and now we're doing the software, which is an SDK. What we did is we included our libraries that we needed. We initialized our XGPIO instances, and we set the data direction register for them to show that they are either inputs or outputs. We used some built-in functions. We used discrete read and discrete write. We used discrete read to get the data from the input in the processing system. If you remember, the input from the processing system is actually coming from the FPGA fabric. Then we used that and said just invert it, which is the equivalent of a NOT gate. Then we use this function xgpio discrete write to write the output data to the LED instance. Now we are going to minimize this to get back to the thing that we need. Okay. And you're going to want to plug your FPGA in. If you don't, I do not have mine plugged in. Give me 1 second. And I'm going to plug it in. What we're going to do is, okay, before we actually try it, I'm actually going to do this. I'm going to include the print, I'm going to include the print function. And we're just going to use this for like a debug statement, and we're going to print we are up, just to make sure that our code's actually running. So debug to see if code is running. What we're going to want to do is set up a terminal. I think this is 11.5.200 baud rate. Yeah. I think that's the default. You can change it. Make sure you set it the right port. We're going to connect to a serial port. Click OK. If you don't know how I did that, I went down to, we were at the console. I went over to the SDK terminal tab. I selected this plus button and I configured it there. The baud rate was already set. I'm going to say baud 11.5.200. And it says connected to COM6 at this. We're going to clear it so we can see any messages that pop up. Now, we don't have our FPGA programmed yet, so we're going to go up to the top. And we're going to say Program FPGA. It should have your bit stream that we generated in Vivado. Sorry, my phone's going off again. Already up there. If it doesn't, you can browse for it, and I will show you where it is. We're going to go to where your Xilinx folder is. Go to I have a projects file. Go to your project. Go to the SDK folder and Design One wrapper hardware platform. Click on that, and that's where the bit stream should be located. And we're going to click program. And it's going to take 1 second, and it looks like my FPGA is saying that it's programmed successfully. Now we're going to go to not gate, right click on it, click run as, and launch on hardware. And I needed to save it, so I'm going to save it. And you can see it's launching the system debugger. And SDK terminal, if we click on that, it says we are up. So that means the UART is working on the ZYNQ processing system. So that's good. And yeah, so I'm going to take a little video of my board showing you that it's working. Okay, so what we just did is we created a AND gate in the programmable logic. If we just, let's say we pretend divided up this chip in two, this half is the processing system and this half is the programmable logic. This part is holding an AND gate and this part is holding a NOT gate. The NOT gate is in software, the AND gate is in hardware, and we connected them together inside the chip to form a NAND gate. I have these two switches which are connected. Since they are both low and this is a NAND gate, the output is high. If we put one high, one NAND 0 is 1. And if we put the other one high, one NAND 0 is also high. But if we put both high, one NAND 1 is low. Put them both low, 0 NAND 0 is high. Yeah, I think I said that right. But basically, it works exactly the same as a NAND gate, which is cool. I like that. So I hope you really enjoyed this project. Like I said, I'm going to try Vitis after this. I'll probably install it tonight. So wish me luck on that. The installation is what looks like is 110 gigabytes, which is nuts. So that's going to be fun installing. But I hope you liked this video. If you have any questions, you can leave it in the comments below, or I can direct you to my Instagram where you can send me a message. That's actually how I got the idea for this video, was a message on Instagram. So just send me a message if you have any questions and we'll try to help you out. All right, bye.